Dear students, how are you? Welcome to our new class of physics. This is our last class on reflection of light, which is chapter number 8. I am your subject teacher, Noman Muttaki, lecturer, Department of Physics from Milestone College. So students, let's start the chapter with image formation in concave mirror. In our previous class, we have discussed about it. But in our previous class, we have discussed on a figure which was on a concave mirror, image formation of concave mirror. But in this class we are going to discuss on minimum 5 or more figures or formation of images. Let's talk about the first one. This is the first figure. This is for concave mirror, and now this is for position of the object which is at the center of curvature. This is the concave mirror. This is the concave mirror, and this is the principal axis of this mirror, and this is the center of curvature of the mirror, and this is the focus of this mirror. You know, the focus is situated in the middle of center of curvature and the pole. So we are now drawing the object just at the center of curvature, as the figure or the description shows that the object is at the center of curvature. So this is the object. This is the straight object, and there is a ray from the head of the object or top of the object which is parallel to the principal axis, and it will reflect through the focus or the principal focus. We have to consider another light or ray from the head or top like this through the focus, and it will reflect just parallel to the principal axis like this. And there is the image. This is the image which is inverted, but the distance of the object is equal to the distance of the image. This is very interesting here. Now this is the position of image. The position of image is at the center of the curvature. That means if an object is situated just at the center of curvature, then the image will form just at the center of curvature, and the size of the image is equal to the object. This is also interesting. And nature of the object is real and inverted and real, as you can see. There we will discuss about another figure, which is figure number 2, and there the position of the object is away from the center of curvature. This is your concave mirror. This is the principal axis. This is center of curvature. This is focus, which is just at the middle of pole and center of curvature. There is the object which is away from the center of curvature. This is also a straight object. We have to consider the first ray, which is parallel to the principal axis. It strikes to the on the concave mirror and reflects through the focus, and there is another light through the focus, and it will reflect just parallel to the principal axis like this. And here we will get the image. This image is something like diminished. That means this is smaller than the object, and this is the description of the image. The position of the image is between the center of the curvature and the focus, and the size of the image is diminished. Obviously, nature of the image, it is real and inverted. These two figures are important for you. We are now going to discuss on the next slide. Student, this is our next slide. This is our present slide actually, which is about figure number 3 and figure number 4. This is our figure number 4, and the position of the object in this figure is between the center of curvature and focus. This is the concave mirror. This is the principal axis, radius of curvature or center of curvature. This is the focus or principal focus. This is the position of the object, as we have said before, between the center of curvature and focus. The object is in between the center of curvature and focus. There is the first light, the reflected ray, second light, the reflected ray, and this is the formation of the image. This is not diminished, this is not equal, this is magnified than the object. That means when you placed the object in between the center of curvature and the focus, you will get an inverted image, obviously, but the image will be inverted and magnified. That means larger than the size of the object. This is the position. This is the description of the position of the image. The image will be at away from the center of the curvature, and the size of the image is magnified, and the nature is real and inverted also. This is the figure number 4. Here we will discuss of an object which is at the focus of a concave mirror. This is the concave mirror. This is the center of curvature and focus and principal axis, and this is the object which is at the focus, just at the focus, and this is our first ray which goes parallel to the principal axis and come back. It just comes back just through the focus. This is the reflected ray. There is another ray. We have to consider the ray just straight to the center of curvature, just straight to the center of curvature. This is the incident ray, and the ray will reflect just through the line, but it will go back like this. This is the reflected ray. As the ray goes just parallel or just through the center of curvature, it will come back through the line, just through the line. And the image, there is no image actually, here is no formation of image, but the description shows that the image will form at infinity. The size of the image is magnified, the nature will be real and inverted. That means if you can put the object just at the focus, then you will get an image which is at the infinity, but this will be magnified and real and inverted. Now this is figure number 5. The position of the object is between the focus and the pole. This is the first ray, and the object is between the pole and the focus. This is our first ray, just parallel to the principal axis. This is the reflected ray, and this is the second ray, which is just through the center of curvature, and it will come back through the center of curvature like this. And in this case we have to draw some extended line like this. This is the extended line for the reflected ray. This is another extended line for the next another reflected ray, and there we get the image. This is the virtual image. This is really the virtual image, and it is magnified. It is magnified. That means if you can put the object in between the pole and the focus, then you will get an virtual image. This is a virtual image, and it is not inverted, it is erect. This is the description. The position of the image is behind the mirror, size magnified, and nature is virtual and erect. You must draw these figures in your copy and practice again and again. We will go with the next slide. So student, this is our next slide, which is on important equations. Obviously this is very important for you. This is the first equation, 1 by u plus 1 by v equal to 1 by f. This is your first equation for this chapter. We are going to use this for solving our problems or mathematical problems. This is second problem, which is f is equal to r by 2. We have mentioned it before. F is the focal length and r is the radius of curvature, and as the focal length or the focus is in between the pole and center of curvature, that means the focal length is half of the radius of curvature, right? This is the third equation, which is about magnification. This is very important. What is magnification? Magnification means the size of image, then the objects. The size of image then the object. This is the first equation, m is equal to minus v by u. And another equation on magnification, m is equal to l prime by l. You have to keep in your mind that v means the distance of the image from the pole of the mirror, and u means the distance of the object from the pole of the mirror. L prime means the length of the image, l means the length of the object. So these two equations are very important. First equation, m is equal to minus v by u, which is for the distance of the image and the object, and you have to use the next one, which is m is equal to l prime by l. This is very important for determining the length of the object or length of the image. So here the important line, u is equal to distance of the object from the pole, v means the distance of the image from the pole, f is the focal length. This is the distance from the pole and the pole, from the pole to the principal focus. This is r, which is radius of curvature. what is this is m, which is magnification of the image. By doing this, we can get the length of the image, or the size of the image. This is small l, which is length of the object. This is l prime, which is length of the image. So write down the equations. You have to write down the equations more than 5 times or 10 times. It will be better for you. So we are going to discuss on the next slide. This is important information. This is actually related to mathematical problems. Number one, when f means the focal length, when f remains positive, when the focal length remains positive, then the mirror is concave. Concave mirror's focal length is always positive. When the focal length f remains negative, it means the mirror is convex. If the value of v remains positive, v means what? The distance of the image from the pole remains positive. When you can get the value of v positive, like v is equal to +1, +2, +5, then it means the image is real, not virtual. But if the value of v remains negative, like -2, -3, or -4, the image is not real, this is virtual. For convex and concave mirror, in special cases, we can get the virtual image. In our figure number 5, we have discussed on this. M is equal to 1 means, what is m? M means magnification. If you get the value of m 1 means the size of image is equal to the size of the object. But if m is equal to 2, that means the size of the image is double than the size of the object. If m is equal to 3, that means the size of the image is triple than the size of the object. But if the value of m remains positive, like +1, +2, +3, it means the image is inverted. Positive means the image is inverted. If the value of m remains negative, the image is erect. Students, by mistake, I have written something wrong. Like, if the value of m remains positive, then the image is erect, not inverted. And if the value of m remains negative, the image is inverted. That means inverted image for the last one. The image is not erect, the image is inverted. Thank you. That's good. This is for mathematical problem. This is very important mathematical problem. There is a concave mirror which has a radius of curvature 4 centimeter. That means the focal length must be positive. There is an object of 1 centimeter just at the middle of the focus and pole. Find the length of the image. Just imagine about our figure number 5, where we have got an virtual image, as the object was at the middle of the pole and the focus. Let's go with the solution. This is the solution. Find the length of the image. That means you have to determine the length of the image. We know the equation for length of the image. M is equal to L prime by L. As M is the magnification, L prime is the length of the image, and L is the length of the object. So this is our next line. We can write this line like this: L prime is equal to M multiplied by L. Here L prime is the length of the image and L is the length of the object. M is the magnification. To solve this problem, we have to know the value of magnification and the length of the object. So we have to write another equation, like again M is equal to minus V by U. This is about the magnification also. M is equal to minus V by U. By using this equation, we can determine the value of M. For doing this or to do this math, M is equal to minus V by U. We have to know the value of V and U. What is V? V means the distance of the image from the pole. U means the distance of the object from the pole. So we can use this equation to solve this problem. Here we know this 1 by U plus 1 by V equal to 1 by F. We have to use this equation 1 by U plus 1 by V equal to 1 by F to know the value of V and U. In our question, there is the value of U. Where is the value of U? Look at the question. There is a concave mirror which has a radius of curvature of 4 centimeter. Radius of curvature means R. We know the equation f is equal to r by 2. By solving this problem, we can find the value of f. But there is an object of 1 centimeter, this is the length of the object, just at the middle of focus and pole. Just at the middle of the focus and the pole. So let's go with the line here. 1 by u plus 1 by v equal to 1 by f. We can write this line by 1 by v equal to 1 by f minus 1 by u. So 1 by v equal to 1 by 2. Why 2? 2 means the value of f. Why? Because f is equal to r by 2 and the value of r is equal to 4. 4 by 2 is equal to 2. This 2 is the value of f. Okay, that means the distance from the pole to the principal focus, is 2 and the object is just at the middle of the focal length. That means from the pole the distance of the object is 1 centimeter. Again, I can explain this. We have got the focal length f is equal to 2 as the radius of curvature is 4 and we know f is equal to r by 2. By solving this problem we have got the value of f. Focal length means f is equal to 2 and in this equation we have got the message that at the there is an object of 1 centimeter just at the middle of focus and the pole. That means from the pole the distance of focus is 2 centimeter and as the object is in between the focus and pole, that means the distance of object from the pole is 1 centimeter. So the value of u is 1 centimeter. So by doing this math or solving this math, we have got the value of v, which is minus 2 centimeter. And minus means v, the value of v minus means this image is virtual, not real. If the value of v is positive, it means the image is real, but here the image is virtual. By using the value of v, we can write m is equal to minus 2 by 1. Minus 2 means the value of the v, and we got 2. 2 means what? Positive 2. Positive 2 means the image is erect, not inverted. Think about the figure number 5. The image was erect and magnified. 2 means the image is double than the object. Now L prime is equal to m multiplied by L. The value of m is 2 and the value of L is 1. So the length of the image will be 2 centimeter.